Hello everyone, welcome to this video lesson. In this video lesson, we are going to have an overview of the collisions concept. We have started this in the previous class and we said a collision is a kind of a physical interaction or no physical interaction. That doesn't make a difference. If there is a transfer of momentum, collision is said to happen if there is a transfer of momentum, shown with the letter P in science, physics, and transfer of kinetic energy between or among bodies. In that previous video lesson, we have also defined there are two types of collisions called something like elastic collisions, where both momentum and kinetic energy are conserved, whereas there is another kind of a collision called inelastic collision, where only momentum is conserved but kinetic energy is not conserved. Some kinetic energy is not transferred fully to the bodies after the collision, rather it is converted into a sound, light, or else heat. Taking that basic overview into consideration, let us try writing some mathematical equations of collisions. Let us consider a body of mass m1 initially moving with a velocity u1. Let there is another body of mass m2 moving with a velocity u2. This is the situation before the collision. Let collision happen, and after the collision, body's mass won't changes, but their velocities will change because momentum is transferred and kinetic energy is transferred. They have different velocities. Assuming collision as an elastic or inelastic collision, we know that momentum is conserved. What do you mean by momentum is conserved? Momentum initial of the system is equal to momentum final. Momentum initial is momentum before the collision. So the first body is having some momentum before the collision, as well as the second body. Even after the collision also, these two bodies are having some momentums. Momentum is mathematically defined as product of mass and velocity. So I can write that as m1 v1. I am simply writing m2 v2 because I have assumed that both the bodies are moving in the same direction on the x-axis itself. This kind of a collision is called something like one-dimensional collision. Momentum final means m1 v1 plus m2 v2. This is how we can write an equation for the conservation of a linear momentum. This momentum is conserved along the line, that's why it is called like a linear momentum. There is no rule that collision has to always happen like this only. Let us consider a case. The first body mass is m1, velocity is u1. Second body mass is m2, velocity is u2. But they are moving in the opposite direction before the collision. Let after the collision, both of them are moving in the same direction. Just a possibility. Now again I can apply conservation of linear momentum and I can say m1 u1. I will write minus m2 u2 because I am talking about momentum, which is a vector quantity whose direction also has to be taken into consideration. If I have treated P1 as positive, I have to treat P2 as negative because they are in opposite directions. After the collision, I can put a plus because both of them are traveling in the same direction. This is how I have to write an equation for the conservation of a linear momentum. It may also happen that there are so many possible cases. Let us consider a case like bodies before the collision are moving in the opposite direction, and after the collision again they are moving in the opposite direction. It's quite possible. It can happen. In this case, if I have to apply the conservation of a linear momentum, I would like to write an equation m1u1 minus m2u2, because initially both the momentums are in opposite direction. Even finally also they are in opposite direction, m1v1 minus m2v2. This is called something like a one-dimensional collision. Whether this collision is elastic or else inelastic, these equations are very much valid. Suppose if the collision is an inelastic collision, when we can say a collision as the inelastic collision, or a perfect inelastic collision is after the collision both the bodies won't move separately, rather they will move with a common velocity. So a collision is said to be perfectly inelastic if after the collision both the bodies stick together and moves with a common velocity. Let us try understanding. What do you mean by that? There is a body of mass m1 moving with a velocity u1, another body of mass m2 moving with a velocity u2 before the collision. After the collision, this m1 and m2 together moves with a common velocity v. They don't move separately, rather they move together like a single entity. In that case, applying the conservation of momentum, m1u1 plus m2u2 equal to m1 plus m2 of v common. So we can calculate v common as m1u1 plus m2u2 by m1 plus m2. If suppose somebody say it's a perfect inelastic collision, but the bodies are not moving in the same direction before the collision, rather they are moving in the opposite direction. Let's set a special case, m1u1 m2u2, but after the collision they move together with a common velocity. In that case I can write a formula, m1u1 minus m2u2 equal to m1 plus m2 of v. So one point must be very clear to all of us, that whether the collision is elastic or inelastic, linear momentum of the collision is always conserved. That initial momentum of the collision is equal to the final momentum of the collision. Basing on that, we can solve some simple problems and find the velocities of the bodies after the collisions. Thank you for watching. Keep coming back for more and more video lessons. We'll be discussing the further aspects of collision in the coming video lessons. Thank you.